Okay, so this video is how you can check your work. Obviously, this isn't like a great test strategy because it is kind of time consuming. Although, if you finish tests quickly and you have time to go back, this is how I'd spend my time if you're not sure about the graphing. I don't usually advise students to go back and check their answers on tests because a lot of times they'll just freak out and they'll start erasing right answers. So, I mean, use your best judgment on that. But if you know that you can actually come up with the correct answer, it's worth it. So don't do this on every problem, but like I said, extra time, this is a good use of it. So, okay, so just we're going to make sure, because we had the last solution, we had that as, because remember ax plus by equals c, we had this equation, and we converted it into the standard form that she wanted. But can we be sure that these are equal? Are they right? Well, we'll find out. Here's the best way to find out. Remember with these that it looks like it's like numbers that don't mean anything, but they're all coordinates. So all you have to do is plot them out and you'll see. If it's the same line, then you're correct. If it's not the same line, then you're wrong. So let's start. -1, 0, 1, 2. That should be plenty. So I'm going to put these values on both sides. Now remember, if it's the same line, then we're right. And really, we don't even have to graph it if we get the same solution for y. So you don't even have to bother really graphing it. You only have to do 2 points. If you do 2 of these, that's enough. But, I mean, for good practice, we'll do 4 because I already wrote them in there. So we're going to plug in, let's plug in a -1 in this equation. So y equals, so 2/3 x. So if x is -1, because that's what we're doing here, we just plug in -2/3 times -1. Did I say -1 before? If I didn't, I should have. -1 minus 4. Okay, so now we have y equals the opposite, or -2/3 times -1. So what's a negative times a negative? Positive, right? Minus 4. So -2/3, so that'll be y equals 2/3 minus 4. So 2/3 minus 4 is going to be what? Oh my gosh, hold on. See, my calculator's on my phone. That's going to be what? 3 1/3, right? Geez, that was tougher than I thought. 3 1/3 or 3.3, doesn't matter. Put in whatever you want. So 3.367. I guess I'll do that because the calculator does it. All right, and boom, boom, boom. Let's try it over here. Same one. 2/3 x. Remember, it's the same one, different form. 2/3 x plus y equals -4. So 2/3 x, we're going to use the same number, -1, so that's -2/3. I won't belabor that point, but remember, you times it by, you substitute this for x, so this would make it -2/3. Plus y equals -4. So -2/3 plus y equals -4, and that's going to give us, add 2/3, y equals 4 minus 2/3 is, well, -4 minus 2/3 is going to be -4 and 2/3, right? So I must have done something wrong. What did I do wrong? That's crazy. Let's check. -2/3 x minus 4, right? Boom, boom. So 2/3 minus 4. That totally is. It's like 3 1/3. And then on this side, 2/3 x plus y equals -4. And we've got -2/3 plus y equals 4. So, oh, that's what I did. I added instead. That was my mistake. So how we're going to get rid of this, because it's negative, is we're going to add. So plus 2/3 plus 2/3, which is going to give us y equals -4 and positive 2/3 is going to increase the value by what? 2/3, which is going to be 3 1/3. Is that the same? Boom, it is. We'll do 0 real quick because 0 is super easy. So just sub 0 for this. When x is 0, pretty much that cancels. Y is -4, right? Because -2/3 times x, or times 0, anything times 0 is 0. I know that you know that. Same thing over here. This cancels out. Is y equal to -4? Well, yes, it is. So you can already see here. That you can easily check this by using an XY table, or a T table, as I sometimes call it. And you can plot it if you like. You don't have to. But all right. So that's more explanation you probably wanted, but you do need to know this. And this is the kind of stuff that like you're going to use eventually with like calculus and whatever, all that math that pays good money when you get out. So, all right, that's problem 1.